In this example, the power here is to -3. So in fact, this example starts off as a quotient. So it's 5 minus 15x squared over 5x cubed minus 5x plus 14 cubed dx. And then you can rewrite it as the example which you see here, which is equal to integral from 2 to 1 of 5 minus 15x squared times 5x cubed minus 5x plus 14 to the power of minus 3 times dx. And I can just shorten this integral sign here, like so. And then we follow our normal procedure. So we let the larger function equal to 5x cubed minus 5x plus 14. We let the smaller function equal to g at x, which is equal to, and I'm going to rewrite it the other way around, minus 15x squared, I'll put the higher power first, plus 5. Then I take the first derivative of f at x, so f prime x, and the integral of 5x cubed is 15x squared, and the integral of minus 5x is minus 5. Then we look at the coefficient, the ratio a, so it's the ratio of the coefficient of gx divided by the coefficient of x squared in g at x divided by the coefficient of x squared in f at x. So that gives me minus 15 is a coefficient in g at x divided by plus 15 is the coefficient in f prime x. So that gives us a value for the ratio of minus 1. So then the question is a times f prime x equal to g at x? So a is minus 1, f prime x is 15x squared minus 5. That's equal to minus 15x squared plus 5. So that is equal to g at x. So that is yes. So once we establish that, we're able to use our rule, and our rule is the integral of a times f prime of x times f at x to the power of n dx is equal to a times the f at x to the power of n plus 1 divided by n plus 1 plus the constant of integration. So that's the general formula which we can apply. So if we apply it to this case, it's minus 1 times 15x squared minus 5, which is f at x. So if we look at this, this is a, this is f prime x. And then we put in f at x, which is 5x cubed minus 5x plus 14, and that is to the power of minus 3 dx. Just change this to a normal bracket. And if we apply our rule, then that is equal to, and we're going from 2 to 1, so that is equal to a, which is minus 1, times 5x cubed minus 5x plus 14. Our power up here is minus 3, so we add 1 to get minus 2, and we divide by the minus 2, and that is going from the upper limit, which goes from 2 down to 1. We're going to evaluate it between those two limits. So minus 1 divided by minus 2 gives me plus a half, so I'll put that outside, and I'll write 5 minus 5 plus 14 to the power of minus 2 minus, where's this, 5 minus 5 plus 14 to the minus 2. So I'm going to put those in here. If I put the upper limit in as 2 cubed minus 5 times 2, so it's 5x cubed, where we put in 2 for the x, so it's 2 cubed minus 5 times 2 plus 14. And on this side, our lower limit is 5 times 1 cubed minus 5 times 1 plus 14. All to the power of minus 2, so that gives us a half times 2 cubed is 8, 5 eighths are 40. So it's 40, 5 minus 5 times 2 is 10, plus 14 to the power of minus 2. So that's basically 1 over that lot to be squared, minus 5 times 1, so it's 5 minus 5 plus 14 over minus 2, so to the power of minus 2. And that gives me a half over 1, and I'll bring it in underneath now. So this is 40 plus 14 is 54, minus 10 is 44. It's that lot to be squared, so the minus 2 now becomes plus 2 over 1 minus, and here that goes to 0, so we're just left with 14 squared. Okay, and you can evaluate that with a calculator, which I will do shortly. So this is equal to 1 over 2 times 44 squared is 1,936 minus 1 over 14 squared is 196. So if I evaluate this, we get 1 over 2 times this 1 divided by 1,936 is 0.0005165 minus, and then we have a 0.005102, and that gives us minus 1 over 2 into times 0.00458, and then if we divide that by 2, we get minus 0.00229. So it's a very small number anyway. So that is the answer for that one. Okay, thank you.